So we were talking about special right triangles, and we're talking about 45, 45, 90 triangles. And we want to use properties of 45, 45, 90 triangles to solve problems. So here's the question. What is the length of the diagonal of a square whose perimeter is 60 inches? So first thing I'm going to do is I'm going to sketch a square. It's not going to be an exact square, but it's going to be pretty close. So we want to have all the sides equal, and we want to have all the angles 90 degrees if we can help it. And the question says, what is the length of the diagonal? So I'm going to sketch the diagonal on here. And although I may not have drawn it extremely accurate, what we want is, because it's a square, all sides are congruent. Next piece of information. What angles do we know? So this is a square, so we know that all the angles are 90 degrees. So that means that if this is 90 degrees here, then this is our hypotenuse. Now, because this is a square and diagonals all are bisected, that means that these two angles are both 45 degrees and they're congruent. So that's 45 degrees and that's 45 degrees. So this is a 45, 45, 90 triangle right here. The only thing we need to know now is what is the distance of our legs. Now we can calculate our h value. So the perimeter is equal to 60 inches. And all the sides are congruent. So the length of the side is going to be equal to 60 divided by 4. Because all the sides are equal and there are 4 sides in a square. So 60 divided by 4, and that tells us that that is equal to 15 inches. So each side is equal to 15 inches. Now we can use our relationship that we know for 45, 45, 90 triangles, where h is equal to the leg times the square root of 2. So in this case, our hypotenuse, oh, forgot to write my 2 in there, square root of 2. So our hypotenuse is equal to 15 times the square root of 2 inches. And that is our solution right there.